Good afternoon, everyone, and welcome to the World Soil Day Seminar 2021, conducted by Land Development Department, Thailand. My name is Prof. I am here as your master of ceremony today. For the first session of this afternoon, we are very happy for having a very special guest joining us as a keynote speaker today, Professor Masaru Mizoguchi from Graduate School of Agricultural and Life Science, the University of Tokyo, Japan. Professor Mizoguchi has been actively working on agricultural information engineering relating varied fields such as soils, water, agriculture, climate, and very interesting at some point with radioactive cesium. And if you recall the news 10 years ago on the accident of Fukushima Daiichi nuclear power station in Japan, this disaster dealt a lot of damage, and this impact environment, water and soil contamination, for example. So today we are pleased that we have opportunity to hear the talk on such occasions and so far how it impact on the livelihood and agricultural area from Professor Mizoguchi. And after the talk, we can discuss on how we can relate this to soil salinization. Professor Mizo, thank you very much for joining us today. And I have heard from Kun Somsak that you have been work in Thailand for some time, many years ago. Is that right?
Yes.
Yeah. What were you doing in Thailand by that time?
At that time, I visited Konkan area, and I set a field monitoring system, which everyone can collect the data using the system. So I introduced the soil sensors and data logger system to Thailand.
So are you still working with the soil sensor at the moment?
Right now, Malika is using such systems.
All right. I know Dr. Malika, she is very good. Professor Mizo, if you are ready, the floor is yours.
Okay. Can you see?
Yes.
Okay.
Very clear.
Clear?
Yes, very clear.
Okay. Sawadee krap. Pomochu Masaru Mizoguchi kap. Today, I'm very happy to be here, and I will talk about my research in Japan. The title is Resilient Soil Science Starting from Fukushima. Introduction. 10 years have passed since the Great East Japan earthquake. Researchers from various fields have been involved in soil and agriculture issues since the earthquake. There are two soil damages caused by the earthquake in Japan on March 11, 2011. One is salinization by seawater. Another is contamination by radiocesium. This is a yellow part were damaged by tsunami, and the red parts were damaged by nuclear power plant accidents. But both of the problem, interaction between clay and cation is very important. So today I'll talk about this mechanism and method to solve the problem. First of all, I'd like to talk about the nature of clay. The clay surface is electrically negative. So cations such sodium, which are hydrated with water molecules, are adsorbed onto the clay surface like this. The hydrated cation are easily replaced by other cations, such as potassium. However, the cesium released from the Fukushima nuclear accident, nuclear power plant accident is strongly absorbed directly onto the clay surface. When considering soil desalinization and decontamination, it is necessary to understand the difference in absorption type. This is a picture of farmland hit by tsunami in 2011. Like this, almost all area of Tohoku coastal area were damaged by tsunami like this. This picture were taken by the Miyagi University or Iwate University researchers. When we think about the desalinization of farmland immersed in seawater, there are several important points. A large amount of sodium chloride, so-called salt, remained on farmland that had been exposed to seawater. Second, the salt prevented the crop roots from absorbing water, so salt removal was necessary. To this end, it was effective to wash away the salt with fresh water. There are two methods in agriculture engineering. One is leaching, vertical infiltration, which simply pushes the salt underground. And second one is elution, which dissolves salt in the water and drain it. So we try to monitoring of soil during desalinization process. We set soil sensors which is easily collect the soil moisture content, temperature, and electrical conductivity of soil. Like this, we set the soil sensor at the depths of 5, 10, 15, 20, 60, 25 centimeter, and then collect the data using the data logger made in your Decagon company. And the right-hand side is one of the example of the moisture content, electrical conductivity according to the precipitation. Anyway, like this, we started to collect the data from the field. And then we applied the desalinization method by draining irrigation water discharge from underdrain. Because in Japan, we have much rain in rainy season, June or July, and the typhoon season in September. Therefore, salt removal was possible within a few years by constructing a drainage channel. This is the mechanism of underdrain technology, which is useful for restoration of salt damaged farmland. Like this, we dig a hole to make a drainage like this and canal, and put the fresh water from the canal and then under drain under the ground, the salt will infiltrate together with fresh water and then flow down to the drainage. Like this, it's a little bit easy to collect the salt from the farmland hit by tsunami. On the other hand, nuclear power plant disaster in Fukushima at that time. Fukushima prefecture was contaminated by radiocesium due to the nuclear power plant accident, in addition to the tsunami hit. While the 1986 Chernobyl accident was brought to an end with cyclocapaz treatment. But in Fukushima, the first human challenge to revive the region continues in Fukushima and accumulate its experience as a reconstruction knowledge for 10 years. I'm now in charge of this work. The reconstruction agency in the Japanese government is trying to create an international education and research center that will be the core of creative reconstruction, including an attempt to disseminate such reconstruction knowledge to the world. This is the concept of restoration of contaminated topsoil. The radiocesium that is strongly adsorbed, professionally fixed on the clay surface, accumulate in the topsoil layer. Removing cesium from clay is not as easy as removing salt. Because the radiocesium is fixed on the clay surface. Considering cesium and the clay particles as one, like this, removable of clay means decontamination. Based on this idea, we developed two decontamination methods. One is flushing out muddy water after mixing topsoil and water. And second one is burying the topsoil on the ground with non-contaminated soil. According to the field investigation, radiocesium was accumulated within the 5 centimeters of soil, not moved downwards. This is one field study data. It looks like a pudding. You know, this is a cesium contaminated part, and this part did not move downwards. So Japanese government made a manual using the 3 methods to decontaminate the contaminated soil. One is a stripping topsoil method using this kind of heavy machine. And second one is soil paddling method, mixing the contaminated soil and water. And then after that, flush out the muddy soil. And the third one is a deep plowing method. This is the decontamination trial by NPO members. It's 2012. Can you see? This is Kum Sak. He visited the Itate village, Fukushima, 9 years ago, and he talked with the president of NPO and by local farmer Muneo-san. Like this, thank you. I'm very thank you. Thank Somsak to visit the Itate village. And this is the decontamination practice by collaboration of farmers and NPO members. This is the decontamination method by stripping frozen soil, because the Itate village is very cold in winter season. So the soil is frozen about 5 or 10 centimeters. So it's easy to correct the contaminated soil. And second one is rotary weeder method. In Japan, in old days, farmers used this rotary weeder machine and then mix the soil and wheat. And so I hit upon using this equipment to get muddy. And then, oops, sorry, I forgot. I put another information. Oh, which one? Sorry, this one. Okay. And then this is another method, soil paddling and deep ploughing method, using the tractor and they mix the topsoil and water and then flush out to the ditch aside the paddy field. And then that muddy soil, flushing out contaminated muddy water into the drain as a result of radioactive activity measured at each depth by sampling the soil of the bottom and side of the groove after the dry up cesium did not infiltrate into the soil. You can see cesium remained just on the surface part, not moved downwards. So we tried another method, the stripping topsoil and buried of contaminated soil, and then soil compaction and covered with this non-contaminated soil. Like this, we succeeded to develop our decontamination of cesium contaminated soil. But people have a question. Does not cesium leak out from the buried contaminated soil? The answer is no, safe. But I want to show the data. I developed a new instrument to measure the soil radiation in a well like this. That's a 1 meter long, 3 centimeter in diameter, and 10 pieces of Geiger mirror tube arranged at the 10 centimeter. And I use this equipment almost every year, near March 11th day. Almost every year I measure soil radiation. And this is a result. You can see that this is a profile of soil radiation level. If radiocesium moves downwards, the peak must move downward. But you can see about 5 years, in 5 years, the peak did not move. The peak depth of soil radiation has not changed. And the maximum of soil radiation level, this are decaying naturally. This is an estimation of soil radiation with theory. This is the red one is one area and blue one is another area. This line shows the theoretical theory. You can see the maximum of soil radiation decreases according to the theory like this. That means once we buried the contaminated soil under the ground, the cesium did not move, and then soil radiation decreasing gradually. So right now, I'm keeping to try another soil problem right now. This is my challenge of resilient soil science and informatics in Fukushima. I have a lot of trial, but today I will show the three. One is composting using IoT sensors to recover the soil fertility that was lost due to soil decontamination work in Fukushima. After the decontamination in Fukushima, soil fertility decreases drastically. So we need to add some fertile soil. So I'm trying to make good compost. Second one is animal monitoring using LoRa communication technology. This is a kind of informatics to protect crops and fields from monkey and wild boar. And third one is agriculture and soil education for young generation to keep sustainable earth. And this is a third one, agriculture and soil education for the young generation. I built by hand the soil museum in the field like this, not a LED soil museum. And sometimes I invite a high school student to the Irate village to educate soil like this. And then I wrote a book. This is The Wonder of Soil. This book contains the method to decontamination of Fukushima soil. And this book is a Japanese version, English version, and Chinese version. What's the next? Why not Thai? Why not Thai? I want to publish the Thai soil book. So this is the last slide, the conclusion. Soil is valuable resource to keep sustainable earth. The interaction between clay and cation is important to solve problems related to the soil salinization and soil contamination. Fukushima was damaged with both soil salinization by tsunami and radiocesium contamination by nuclear power plant accident. But resilient soil science and agriculture are now starting from Fukushima like a phoenix. So let's go to the field and stare the soil and talk with farmers and soil scientists in the world. So thank you very much. That's all in my presentation. Thank you.
ขอบคุณค่ะ Thank you very much for your informative presentations and very excellent job. It's very interesting to know that. I just want to know that how is the farming system so far in that area after 10 years of occasions? What's happened to those people over there?
Some people are returning to the village. But the problem is only the elderly people young generation and not return to the village. That's a big problem. So I'm trying to invite the young generation to the village using some smart agriculture method technology or IoT technology, ICT technologies. So right now, I'm trying to invite the young people in the village. Yeah, of course, some people are anxious about the radiation level, but we are always measuring the environment of in the village. So according to to our data, it's not so severe. Well, people can live. I'm confident to live in the field, but unfortunately, the forest area is not decontaminated. So when we visit to the mountain area, forest area, sometimes we need to take care to visit. Yeah, that's a current situation in Idate village.
Oh, that's great to know that. And what is the situation of the salt, like saline soil in Japan in general?
In general, yeah, in general, it's a coast area in the, for example, has some problem about salinization because seawater enter to the some farmland, but in Japan, as I told in my presentation, there is a very good engineering technology. So we can save the coming the seawater into the land using the underdrain technology. And another, I hear that sometimes in the greenhouse, sometimes in the greenhouse, evaporation occur. And if we put many nutrient into the soil, sometimes the salt come up to the surface of the soil. Maybe in generally, only that problem in Japan.
Okay, I think quite similar to Thailand. And because your presentation talking about 3 manners that you use to manage cesium, right? And I just wondering, what is the best one compare between that 3 manners?
Yes. You know, can you see?
Yes.
This 3 method has some level. If the soil is contaminated in 10,000 becquerel per kilogram, very highly contaminated, for highly contaminated soil is this method.
Stripping topsoil method, yes.
Yeah, and 5,000 to 10,000 this method. And under the 5,000 becquerel per kilogram, this method was used.
Oh, very clear.
But so this method is most powerful. But the biggest problem is of farmer's mind is to they want to use this method because farmer want to clean the soil perfectly. So farmer want to use this method. So, but when we use this method, the contaminated soil, there are a lot of contaminated soil like a mountain. So right now, after the decontamination by using this method, we carry this contaminated soil to other parts. So that's a very big problem.
Okay, thank you very much. And I think the time is quite short for us, so I go with the last questions. How can we apply your research result to recover soil-affected soil in Thailand, according to your experience in Thailand some years ago? Do you have any suggestions or recommendations?
Okay, maybe I try to introduce to the soil sensors and the data collector system. Maybe right now that soil sensor is very powerful to desalinization in Thailand, because right now every people can use the internet in the everywhere. So if you use this ICT or IoT technology in Thailand, maybe it's very helpful to clean up the saline soil. Yeah, I hope. And I'm always happy to help the soil desalinization in Thailand, because I'm very, very, I like the Thailand very much and the Thai food.
Thank you very much, Professor Mizo.